In this video, we're going to look at a simple inequality that involves solving for an unknown variable that's in the denominator of a fraction. Now, why does this complicate things? And that's because we don't know what the value of x is at this point. So this inequality, so this is 2x plus 3 over x minus 4 greater than 1. At this point, we don't know what values of x would satisfy this inequality. It's possible that as we rearrange, or while we're rearranging this fraction, multiplying both sides by x minus 4, we don't know whether we keep the inequality sign pointing in the same direction or whether we change the direction and flip the sign around. So what we're going to do is we're going to employ a method called the method of critical points. Now, there are other methods that you can use, and I'm not saying that those methods are better or worse, but this is the method that I like to use purely because it can be extended, in fact, and it can be applied to harder inequalities and more complicated inequalities than what we see here. Okay, I'm hoping to make a video with a harder inequality so you can see the method of critical points at work. So the first thing that we're going to do is to recognize that first of all we have a fraction. Secondly, the denominator cannot equal 0. So I might just just move this up a little bit. Okay, so in other words, first thing we need to start off with is that x cannot equal 4. Or else you have a division by 0. Okay. Now, what I'm going to do just on the side here is I'm going to start drawing my solution. In fact, I'm going to build the solution, but graphically. Okay. In fact, I might use a different color for this so you can see what I'm doing here off to the side. Okay, so there's a number line, x. Now, x cannot equal 4. So what I'm going to do is probably just put 4 here. It doesn't really matter at this point. And I'm going to put an open circle. Okay, because that's definitely one value that x cannot have. Now, the next thing we're going to do is to make life a little bit easier for us, we're going to replace the inequality sign with an equal sign. Now, what does that do? That finds potentially other points, other circles, okay, from where we can then draw the arrows. So the method of critical points says find the points first. Okay, that's why it's called critical points, because they're very important points. They're critical, in other words, important. And then we determine which way the arrows go. Okay, so we found this. That's an easy one. Then what we're going to do is we're going to find the critical points. When I say points, it could be singular or plural, by solving this inequation or inequality as an equation. Okay, so that's 2x plus 3 over x minus 4 equals to 1. Now that's a lot easier. And I think this is one of the great things about this method is that it actually turns something that might appear complicated into something that's actually quite easy. And you know, that's a lot of what we do in maths is exactly that. Taking something hard or difficult and breaking it down or turning it into something that's easy. So, okay, so multiplying both sides by x minus 4, we don't have the complication of flipping a sign around. So we have 2x plus 3 is equal to x minus 4. Okay, subtracting x from both sides, and we have x on that side there. Subtracting 3 from both sides, we have negative 7. Okay. Now, I'm going to go back to my diagram here, my number line. So I'm going to extend that a little bit. X equals negative 7 is another critical point, so let's put that there. Now, the next question is, do I place an open circle or a closed circle above the negative 7? Go back to the original inequality there. It's not a greater than or equal to, it's just greater than. So another open circle there. I might just extend this number line a little bit more. Okay. Now, we've got pretty much most of it. There's just one thing we need to do. We need to determine whether we place arrows sort of pointing kind of away from the critical points, or an interval that joins the critical points, these points negative 7 and positive 4. So what we're going to do is we're going to test 3 points, just 3 strategic values, easy values, just you can pick anything really. We're going to pick a point somewhere below negative 7 or less than negative 7. So we'll pick a point there, and I might actually pick negative 10, just sort of a nice round number. We might pick 0 here, and probably pick, I don't know, 5 here as well. So the next stage now is to test around the critical points. Okay, so let's test, okay, x equals -10. Okay, we go to the original inequality there, so that's 2x plus 3, so 2 outside of -10 plus 3 over x minus 4, so that's -10 minus 4. Okay, so on the calculator, just enter that fraction in, so we'll do that now, and we'll evaluate it. 2 outside of -10, okay, plus 3 over -10 minus 4. And we get 1.2, or sort of, it's greater, it's definitely greater than 1. Okay, so, okay, and that's true. Now, being true means that this part of the number line, okay, or any x values on this part of the number line to the left of -7 will make the inequality true. So what we'll do is we'll place an arrow there that way. So we're building our solution graphically as we sort of discover which parts of the number line hold true, and the values of x on the number line hold true, and which do not. Now let's test a point in between, as 0 is a nice value. So always try to pick sort of easy numbers. Okay. I mean, I could put the square root of 2, but I mean, why complicate things, right? So testing x equals 0. Okay, so 2 times 0 plus 3 over 0 minus 4. Okay, and 3 over -4, well, that's a negative number. Okay, if you wanted to test that, actually I'm not going to bother. Clearly that's false. Okay. And the last point, let's pick x equals 5. Okay, and check to see that the value of the fraction, okay, so this fraction here is in fact greater than 1. And I suspect it will be. So let's do that. 2 outside of 5 plus 3 over 5 minus 4, and that's really handy. That's nice. So 13, isn't it? That's definitely greater than 1, and that's true. Okay. So going back to our diagram, our sketch, we can draw an arrow pointing to the right-hand side from the critical point 4, x equals 4. So writing this up then as a solution, okay, so therefore, okay, x is or can be less than -7, or do not use the word and. It's one or the other, can't have both, okay. X greater than +4, okay, and that's the method of critical points. Thanks for watching.